Before the workshop starts, we're going to show you how to navigate through the video. Below the YouTube video is the Show More button. Click the Show More button to reveal the index. You can skip to the point that you want in the video by clicking the blue time link.
We're going to look at these two teaching and learning plans, one specifically on the multiplication of fractions at junior cycle, and the other one then is complex numbers, Leaving Cert. So we're going to look specifically at multiplication of fractions. One of my colleagues being smart, I suppose, fractions are easy, and you would think so, because we do use fractions in our everyday life. But we're not very precise in our use of them. You'd say, I'll have a half a cup of tea, but if it's 4/9 of a cup, we'd never say that. They'd be looking at you, wouldn't, if you said you had 4/9 of a cup of tea. So we say, a bit more than a half or a bit less than a quarter. So fractions have really, we don't use them precisely in life. My own personal gripe with fractions as well are the calculator and the modern calculators, where you have the fraction mode in it, and you just put them in and you give students the most complicated fractions to do. And they'll do them on the calculator. And that's great. I mean, that's wonderful to have the calculator, and I'm not knocking it. Calculator's grand if you're working out a complicated question and you want to get the calculations done quickly. Let's face it, if you were an engineer and you were designing a bridge, you're not going to depend on mental arithmetic to do the calculations for you. But it's the understanding of fractions and where that leads us to, or where it doesn't lead to, I suppose. Particularly when it comes on to algebraic fractions at Leaving Cert, or even at Junior Cert, algebraic fractions. I've often found myself reteaching fractions with numbers, you know, the rational numbers again, before we go on to teach algebraic fractions. So while fractions are all around us, we don't. We cut things in half or quarters. We get a pizza and we cut it into, divide it in 8. But if somebody gets a little bit, well, you might have an argument, but if somebody gets a little bit more or a bit less, it's no great big deal. This particular question, 2/3 of 4/5 without a calculator. Now, I know a lot of you aren't in the classroom, but you might just think about it. How would first years handle that without a calculator? And then maybe put it on to 5th or 6th years. This now, anybody here from UL today? Don't mind us taking it. We did a course in UL every autumn, and they told us there that they give this as part of a diagnostic test to incoming first years, and 24% of them got it wrong. And if you think of, you know, like those of your students here, you need high points to get into college now, and yet they can't do that. So there's something wrong. I suppose I'm making the point that there's something wrong with the way fractions are being taught. So these are Chief Examiner's reports over the last couple of years about what's happening in Junior Cert and in Leaving Cert. So Leaving Cert higher level handling fractions. Okay? Incorrect handling of algebraic fractions. Leaving Cert foundation level. So there you have 2 higher level Leaving Certs and a foundation level giving problems with fractions. Junior Cert, common errors were mishandling fractions. And areas of weakness in candidate performance, simplifying algebraic fractions. Now those of us who are teachers, that was no great revelation to us. We kind of knew this is happening and we're kind of getting on with the job, but nothing was really being done to address it. This is what our new Project Maths syllabus says about this particular section. We want to investigate models to help think about the operations of addition, subtraction, multiplication and division of rational numbers. So we want to investigate models. So rather than giving to students just a whole load of rules, which they get thoroughly confused with, if we give them some checking tools or models that they can check their answer in. Now, I don't know if those of you, many of you have heard of Lesh and his translation model, but he says maths can be, I suppose, represented in all these different ways. And they're all interrelated. So you have your real life situations, you have manipulative models, pictures, spoken symbols, and written symbols. I suppose that's where we have been for a long time in our teaching of maths, at the written symbol. So let's see, the real life situation isn't always possible to represent in the class, to actually, it can sometimes, but other times it's not that easy. So we would use some models, manipulative models, and we have found these Unifix cubes to be of great help in lots of different areas of maths. And we also have, with regards fractions, you can get things like fraction stacks and fraction towers. And like the teachers, particularly in first year, should not be afraid of bringing in these things. The students will have seen them in primary school. But they come from primary school where they have been using fraction strips, fraction circles, into second level. And up to this, they've been learning fractions very much as rules, and rules without reason in a lot of cases. Just learn the rules and get on and do it. So we want teachers to use some sort of modelling in classroom. So I'd like you here in class to see if you can model this situation using the Unifix cubes. Cara has 4 pizzas for her party. She decides that a serving will be 3/5 of a pizza. How many servings will she get from the 4 pizzas? So I want you to take something in here to represent the 4 pizzas and then divide them into servings of 3/5. What I did, and I think most of you, except for here, you took 10 to be 1 pizza. A lot of people took 5 to be a pizza. You took 5, grand. So if we want to have our 3/5, we have 1, 2, 3, 4, 5, and 6. Okay, that's 10. But it's this piece here. I went down to all of you, I was asking you about it. And it really is to have a discussion about what fraction we have here. And you very rightly says a fraction of what. So this is, what fraction of a pizza is this? It's 2/5. And what fraction of a serving is it? It's 2/3. Okay, so it gives a bit of discussion. Whereas if you had just done this, and I'll do it in a minute, just done the maths on a 4 multiplied by 3 over 5, sorry, yeah, 4 divided by 3 over 5, we'd end up with the 2/3, okay, but 6 2/3 or 6 2/5. So if somebody said you had 6 servings, right, and 2/5 of a pizza left over, that's grand. Or there's 6 servings and there was 2/3 of a serving left over, okay. And that's just my Unifix cubes with the 2 pieces at the end. So that's our manipulative models, and I think these are wonderful. And if you don't buy them even, you can get Lego bricks. Anything at all that does representation like that will work fine. Pictures. Okay, what pictures can we use? Well, we have this fraction wall. Now, this is interactive, so I'll be showing this in operation in a few minutes. Also, at the back of the teaching and learning plan you have, there is a fraction wall, and that's just a nice version of it where it's all coloured in and that. So we'd hope to get that on the website and you could blow it up and put it up in the classroom. Okay. Also with pictures, students coming into us in second class in primary school should see fraction strips and fraction circles then or fraction wheels. I think it's about third class. So it's good for us to have an idea of what the students have coming into us from primary school. And the NCCA, the National Council for Curriculum and Assessment, have produced a document. It's about 8 pages long, which is called a bridging document. We got from their website, but it tells you briefly what students learn in 5th class and 6th class. So it saves us having to read the syllabus for 5th and 6th class, but it gives us an outline of what students should have when they're coming into it. So it's well worth reading to know what the students have already covered. But of course, we can't take it for granted they have done it, that they know it. I'll come back to that in a minute. So that's our pictures. The spoken symbols. I've been saying to you all day, and you've seen it yourself, the wordy problems and the wordy answers that are required. And students are not going to be able to write down full sentence kind of answers unless they have experience of speaking it first. So we need to I keep emphasising that we need to get the students talking about what procedures they're using, why they're doing it, justifying their answers. And as I said at the beginning of this section, the written symbols is what we've been doing. I don't think I need to speak on that because that's what we've been doing all along. Just mentioned to you, we can't always assume that the students either have covered all the work in primary school or that they have retained it, or if they ever ever sunk in the first place. So we really need to know where the students are at when they come into us, and I'm talking about first years. So we're looking at their prior knowledge, and we have designed a diagnostic test, which again is on our website. And teachers have taken this on board and they've used it as a preliminary step before they go on to teach fractions. So we're going to look at a couple of questions just from the diagnostic test. Okay? And I suppose when we look at it, we say it's very easy, but if it's the mistakes that students make that we actually can discover where they're at. So for example, if somebody picked B as the correct answer here, we can see, well, what can we say about them? What can we see? What way are they thinking? They say 4 pieces, yeah. And they say 3 of them shaded in, but they haven't got the ideas of the partitioning into equal pieces. Okay? I don't know what some of the others would be, but same thing with this one. What fraction of the fraction circle is marked as F? A possible wrong answer would be quarter, yeah, or a sixth maybe, I think, because it's counted there's 6 divisions, but they're not all equal. So do they actually have the idea of the partitioning into equal places? Now this is one I would say I really like. The big problem students have as well is consider what is the unit, or what's the whole, spelled W-H-O-L-E, right, the whole number. So let's have a look at this question here. So if this represents the number 5, how many squares represent a unit? 1. 1 square, right? If this represents 2.5, then how many squares have we for the unit? 2 squares. If it represents 5/8, how many squares represent a unit? All 8 of them. So all of that is the unit. And then we have 5/8 of it. And the last one then is 1 1/4? 4. So the aspect of the unit is no problem. If you give a litre of orange juice, say, to a student and ask them to divide it between 5 people, they don't have a problem with that. But if you give 2.5 litres and ask to divide it between 7 people, you know, the unit is the 2.5 and not the 1. So that's our diagnostic test. So it's important that we know where our students are at before we don't assume that they have all the information coming from primary school. So prior knowledge. Now the concepts, I mentioned some of them there when I was looking at those questions. They need the concepts of partitioning. Now we already looked at that if they're not partitioned into equal pieces. They need the concept of ordering, which numbers are bigger and which ones are smaller, and they need equivalence. I'll come to those in a minute. And they really need to be done before we do addition, subtraction, multiplication and division. And obviously that then is done before we do make our connection with our decimals, our percentages and ratios. And all of this, of course, hopefully will help them with their algebra in Strand 4. As I've already mentioned partitioning, we're going to talk about ordering and equivalence. And what we're really looking for is that they have reasons for their rules, that we're giving them some method of checking. If they're having done fractions and they come to an exam and they can't remember, do I invert and multiply, what on earth do I do with it? At least if they can draw or picture, I mean, okay, they won't have these in with them in the exam, but it's easy to draw them so that they have some checking mechanism or checking tool. So, is 3/4 always the same? I suppose that could better be, I found that was a bit misleading, that slide. Let's say, is 3/4 always the same as 6/8? It depends on the unit. 3/4 of what? 6/8 of what? So if you look at up here, only if the unit is the same. So I'm going to show you 3/4 of the large pizza is not the same as 3/4 of the small pizza. Now, we all know to decide which fraction is larger, we have getting a common denominator and checking them. But it would be nice if we had a few sort of more informal methods of deciding which fraction is bigger. I have a visual, almost like a visual idea of it. Now, there's no problem really when it comes to numbers or fractions that have the same denominator. But in this case, like if you were trying to explain, a student was trying to explain to you, or you were trying to explain to a student, I should say, why 5/7 is bigger than 3/7, what would we say? You could also say, like, for example, if you think of 1/7, okay, 1/7, And you've got 3 of these 1/7 here, and you've 5 of them in the second place. So there's more 7s in the 5/7 than there are in the 1/7. Okay, 2/3 or 2/5. Maybe we start with, if you were to visualize 1/5 and 1/3, which is bigger, the 1/3. So if you have 2 of those, so you have 2/3 and 2/5. So when the top number is the same, the numerator is the same, that's the way of doing that. You just think of, which is the bigger fraction, the thirds or the fifths. Okay? That's grand. 1/3 is bigger than 1/5. This is where the difficulty can arise. 5/9 or 3/7. So comparing them to each other, first of all, and then comparing them to something else like a half. Now this one is a grand one for maybe my fraction walls. Sorry, my fraction walls on the next slide. So we have 3/5 or 2/3. Now the fraction wall is given to us like this with the halves, quarters and that. But it's very easy to turn them into any fraction we like. I make these into thirds. So I want 2/3 of that. And I can make this into fifths. And we can see very clearly that the 2/3 is greater than the 2/5. Now, students won't have obviously access to the interactive one, but they've been used to drawing fraction strips from primary school, so they can still use that. Now there is another way you can do it. If we double each one, let's see what we get. We get 4/3, which is 1 1/3. If we double that one, we have 6/5, which is 1 1/5. Now if we compare them, they're easier to compare. So we can say this one is, the fifths are smaller than the thirds, this one is smaller than this one. And again, that's something I must say I would not have thought about, only somebody showed me. But they're sort of informal ways of comparing the fractions without resorting to the calculator or decimals. We're going to look at multiplication of fractions. So before we look at multiplication of fractions, we've got to see whether the students actually understand multiplication of whole numbers. So we're going to look at this situation. Liz wants to give each of her 3 friends 4 bars of chocolate. How would you work out how many bars she needs? Is there any other way we could come up with 12 without doing 3 multiplied by 4? Was there any other way of getting 12? In words or symbols, I don't mind which, words or symbols. But what I've seen most people do, just looking at them, is repeated addition. 4 plus 4 plus 4. You could have, I said you could use words, so you could write down multiplied by, or times it. You can write down your repeated addition, okay? Or we can have 3 groups of 4. So that was words to explain it. Okay, so that was multiplication of a whole number by a whole number. Now we're going on to multiplication of a whole number by a fraction. So Barry is having 4 of his friends over to his house for pizza. You can see my colleague who designed these obviously has a liking for pizza. He's going to give them 2/3 of a pizza each. First of all, how is this like the last problem? You can do it like a repeated addition, yeah? You're sharing something between a group of friends. How is it different to the last one? It's a fraction we're giving out rather than a whole number. Okay, now, if you have 4 groups of 2/3, how many 1/3s have you? So this allows you to count your 1/3. How many 1/3s have we? We have our 8. Okay, so we have our 8 1/3s. Now, how many pizzas will Barry need for his friends? So you could have a discussion then. Well, okay, can he have 2/3 of a pizza? He'd have to buy 3, won't he? He'd have to buy three pizzas. How many? You could ask, if you really do want the answer 2 and 2/3, you'd have to probably restate the question and say, like, how much pizza would his friends eat in total? All right? Or you could also ask, right, okay, if he's to buy a whole number of pizza, what fraction of pizza has he left over? So there's lots of extra questions that we can ask on it. Okay. Now, we've found the students love drawing posters. I think some of the teachers do as well. So what we would look at something here is a poster would have pictures, words, it'd have the multiplication sentence on it, or we'd have groups of, you'd have words and you'd have a picture in it to illustrate the multiplication of a whole number by a fraction and not to use the circles, so to use something else. So we get students to actually make posters. What I'm about to show you are, we've asked students' work that we've got from from the schools. We've put it up on our website. You'll be able to see some of it's to do with geometry theorems and other bits of it's to do with statistics. So, I mean, that question really is what we were doing is, when you break it down, this is the question we were actually trying to work out, 4 multiplied by 2/3. And we've got 2 2/3 for the answer. But if you look at 4 multiplied by 2/3 and you just gave a student that straight away. Now, it's not something you wouldn't, as a teacher, you don't put up wrong answers. But as teachers, you need to kind of get into, if you see a wrong answer, you need to get into the head of the student to try and find out where they've made a mistake and why they've made a mistake. So that's why I have, what incorrect answers do you think you might get here? You might get 8 over 12, a very common mistake. Very common mistake. They'll multiply the top and the bottom by 4. But if you get them to cancel back down again, the 8 over 12 cancels down to 2/3, and you ended up, your answer is 2/3, the same thing as you started with before you multiplied by 4. What other incorrect answer might you get? 2 over 12. Sorry, where did that one come from? Cross multiplying. Yeah, that famous cross multiplying is probably the worst thing that ever was introduced. Cross multiply, no equal signs. Cross multiply when ever there's fractions, you cross multiplication. I try to keep away from it by never using it. It's a grand shortcut for any of us who understand it, but try never to use it. I always say multiply both sides by whatever the common denominator is. And another one too is that some students, they get the rules for multiplication and division mixed up, and you could end up with 4 multiplied by 3 over 2. You end up with 6. So it's to learn for ourselves as teachers, to learn from the incorrect answers that the students give us. And it was just looking at the number 4, the number 4, I mean, I think most of us would probably teach us something like that by putting the 4 over 1. And that gets away from not multiplying the bottom line by 4 as well. And we had this over here then, the mixing up. And you need to kind of get in your head, if students ask you, well, look, when you're multiplying, we can multiply the top and we can multiply the bottom. How come when we're adding, we can't do it? So you have to kind of look maybe at the multiplication as repeated addition, or come up, but they will ask you. And I don't have any definitive answer except to work through, if you see practical examples done, rather than just teaching them rules. And I know, and rules without reasons they just don't remember. But if we're giving them models from multiplication, we're giving them checking tools. So this is the last one of these, a fraction by a fraction. So you can see where we were going with. I've gone quickly through the teaching and learning plan. We started with whole number by whole number by fraction, and now we're looking at fraction by fraction. So Cara has 2/5 of her rectangular, we got away from the pizzas, rectangular birthday cake left over from her party. She ate 3/4 of the leftover cake. How much of the full cake was this? How much of the full cake did she eat? That's what I'm asking you. Because a lot of people give me the answer, how much is left. How much of the full cake was this? I know you had your lines going across that way, but it's pretty much the same as what I have here. If we have 2/5 left over, right? So there's our 2/5 that are left over. All right? And we now want to eat 3/4 of that. So I want to divide this into quarters, and since there's one line down here already for me, all I'm going to do is go across like that. You don't even have to go the whole way across, but just across. So she's eating 3/4 of, we say, the red part. And the question is, how much of the full cake was that? It was 3/4 of what was left over, but if we look here, how many units, or many pieces have we divided the cake into? 10. That's why I brought that line the whole way across, so that we could end up with 3/10, isn't it? Okay, just the slide has it done a little bit differently to this. In the slide, there's your 2/5. And to get 3/4 of that, it was actually divided across in 4. The line down here was ignored. So if we take 3/4 of that, so that's all in 20ths now. So we have 6/20ths, which of course cancels down to 3/4. And let's have a look. I mean, basically what we were doing, we were getting 3/4 of 2/5. And we can do the multiplication on it. 3/4 multiplied by 2 over 5. If you don't cancel down, you've got your 6 over 20, which is your 3/10. Or if you cancel down, you get your 3/10. So we have, if you like, the traditional maths way of doing it, we have drawing our diagram and we have using the Unifix cubes. So we're modelling it for the students are modelling it, and they also have ways of checking their answer at the end. And we're hoping that in an exam they won't give us something like that. Okay, that we have, oops, we put that in. I hate seeing things that are wrong on the slide. So we hope that they won't just cancel the 5s, that they'll understand. So that's where we're hoping to go with our fractions. We're going to look at the teaching and learning plan on complex numbers. So we're doing a Leaving Cert one now. And again, just like the one on multiplication, the multiplication of fractions, the setup in the teaching and learning plan is the very same, but there's a few little extras on this one. If you look at pages 26, you should have a copy of this plan in front of you. So on pages 26 and 27, you've a possible introduction to complex numbers. It's going through the very starting with your natural numbers, and then it's coming up with equations, and you don't have enough numbers within the natural number system to answer certain questions, so you move on to integers, and from there to the rational numbers and so on. And when you're going to end up looking for something like the square root of a minus number, at junior cycle you sort of maybe finish off by saying, well, you can't get the square root of a minus number, end of story. But you're into your Leaving Certs, and we're taking that a step further. On page 28 of the book, it's interesting, is the history of complex numbers. What I found particularly interesting was page 3, where it gave us some real-life context for complex numbers. Because you will find students asking you, what use are complex numbers? They can see a necessity for real numbers, but complex numbers and square root of minus numbers and i's, and the usual question, when will I ever use that in my everyday life? Before we do that, there's also a checklist on page 39 of the booklets. And it really is what the students will use. It's self-evaluation. So what do they know already? What are they uncertain about, and what don't they just know anything about? We also have this rule card where students could write down the rules for addition, subtraction, multiplication and division. So let's have a look. I'm going to show you just a Geogebra file. Geogebra, if you haven't already discovered it, it's a free download. I have Geogebra 3, there's actually version 4 up now, but you know, when you're in the middle of workshops and that, I hate downloading something else in case the things that I already have don't exactly work. What we have here are our complex numbers, 0, W1, W2 and W3 to start with. If I added, was it 4 plus I to each one of them, and I got then W1 plus Z, W2 plus Z. And then you were asked, I know that looks a bit messy at this stage, we were asked to join the original number to the one you got when you added Z to it. And when we joined them up, we ended up with this. We ended up with 4 directed lines with the arrow going from the original towards the answer, the addition. The multiplication by I is also a very interesting one. So we started with our complex number 3 plus 4i, and we multiplied it by I. What do we get? Okay, you end up with 3i plus 4i squared, which is 3i minus 4, or minus 4 plus 3i. Okay, so we put in that number. So we started with 3 plus 4i. We ended up here getting what we said was minus 4 plus 3i. Right, the next time we multiplied by I, we got, if I'm right, minus 3 minus 4i. Minus 3, 1, 2, 3, 4. Minus 3, sorry, down there a bit. Minus 3 minus 4i. And over here we got 4 minus 3i. And students will get that much. Now, it's not as obvious as the last one where we joined them up and we saw all the translations. And students at junior cycle will have done axial symmetry and they've done central symmetry. So they might look first of all for an axial symmetry, but they see that falls down. So what I'd ask them to do then is to join each of the points back to the origin, back to 0, 0, right? So we end up that one there. And they'll notice that that one is right through, so of course central symmetry is coming to mind then. But remember, we didn't go from that one to that one. We went from this one to this one to this one to this one. Okay, if I had it done right, it would be something like that. Okay, it should be there. So I'd ask the students then to draw or to measure the angles. So they'll find that each of these angles here is actually 90 degrees. Okay. Can you see now where this is leading to? What will we do next? Compass, take a compass. Now, if they didn't see that, I'd actually say to them, well, can you use this with the diagram you've drawn? So they'll put the point of the compass here, and, oh yeah, you probably have asked them as well to measure each of these, and that's why it was important to take one square for each one. We measure them, we're going to get the same answer. If you took a different scale on the different axes, you won't get them, right? So we see that all of these are the same, and they're all an angle of 90. So we put the compass there, and we draw it. We should end up with our circle going through each one of them. So I want to put it into words what's happening, right? When we multiply a complex number by I, we're doing if you haven't got the word rotation, we're doing a turn of 90 degrees in an anti-clockwise direction. Okay? Then, the last part of this exercise asks us to multiply by a minus I. And what do you reckon the minus I will do for us? It'll do the opposite direction. So we've made a connection now between addition of complex numbers being translations, things moving forward, and multiplying by I is a rotation of 90 degrees. Now we can look at, there's further exercises in the booklet for you for taking a complex number and multiplying it by a real number. And all that does is stretches it out if it's a number bigger than 1, or it shrinks it if it's a number less than 1. We take the complex number, 3 plus I. There's our complex number 3 plus I. And you ask the students to measure the angle it makes with the positive sense of the x-axis, and we get 18 point, GeoGebra is great, it'll calculate it for you, 18.435 degrees. The second complex number I want to deal with is 1 plus 2i, right? And we measure the angle it makes with the positive set. We call it the x-axis, the real axis. Okay, and we see that angle is 63.4 degrees. Now the students know how to do their multiplication. These exercises come after it. So if we take 1 plus 2i and multiply it by 3 plus I. Let's think what we get. 3 plus I by 1 plus 2i. So we have, can you all see this here? 3 1s are 3, 3 2s are 6i, I, and a 2i squared. Okay, your 2i squared is minus 2, which your plus 3 is 1. So we get 1 plus 7i. And look at the angle it makes, 81 degrees. Now, can you see a connection between the two numbers, complex numbers we started with, and the one we've ended up with? You add them. The length or the modulus. What's the modulus of 3 plus I? Square root of 10, isn't it? You square the 3 and you square the number, the real part of this is 1. So that's the square root of 10. How about the second number is 1 plus 2i, and that's the square root of 5. And the result we got, let's have a look at this, it's 1 plus 7i, and that's going to work out to be 1 plus 49, which is the square root of 50. So, can you see a connection between these and this one here? You multiply them. Okay, so if you're multiplying two complex numbers, the resulting answer you get is got the sum of the angles, and it's the product of the moduli. And that's one of the things that the new syllabus is very big into, is making connections between different strands. That strand 3 is not a standalone strand on its own, that you don't bring in something from geometry, which is what this is, the geometry section. This is strand 2 material. So we're making connections or making links between the different strands. And that's something as teachers we have to keep an eye on the whole time when we're teaching something, that we make connections. So we make connections within strands, obviously, but even within strands, I'm digressing a little bit here saying, but you know, in strand 2, you would have taught trigonometry totally separate to coordinate geometry and separate to your synthetic geometry. But what we're doing now is making links with all of them. You know, you can get a question and it might have some coordinate geometry in it, and it might have some trigonometry in the middle of the question and some synthetic geometry. Similarly here, that's within one strand. Here we're looking at strand 3, complex numbers, but we're making connections to strand 2. Okay, we're going to look at assessment. Now, at this stage there have been quite a few project maths exams for the project schools. But what we're going to focus on is that trial I mentioned to you at the start. As I said before, I'll just remind you again, in autumn 2009, a paper was produced by the State Exams, 3 papers were produced by the State Exams Commission, one for higher, one for ordinary, and one for foundation level. They were trialled in the project schools, and as a result of the trial, there was this report written, which is available on examinations.ie. And it goes through the type of, well, the correct answers first of all and how they were marked. But what's very important then as well is to look at incorrect answers and see how they were marked. So that is much, much more detail than a marking scheme that's available, let's say, for the 2011 exam in the project schools gives you the marking scheme. But this gets you into the head or the thinking of the examiners at the State Exams Commission. So we're going to focus on that. And just a couple of questions that are different, well, we've discovered were different from, let's say, the traditional Leaving Cert. So we're looking at this, it's now called the Sample Paper 2010. They trialled it first of all in the autumn 2009, brought out the report, and then issued the official sample paper. And they tweaked it a bit, but a lot of the questions remain the same. So before I go into that, just to summarise what we were looking at today, we were looking at problem solving. And we looked in this morning at why we had problem solving. We looked at what is problem solving. We looked at some questions. We decided there were some were procedural and some were problem solving. And we came up with, I showed you a definition, or you came up with characteristics of problem solving. Then I showed you a definition of them. We have posters with the different strategies on it. And I showed you some teaching and learning plans which are to help with more active and maths and teaching for understanding. And of course then, at the end of it all, we have this assessment at the end of the junior cycle or at the end of Leaving Cert. I'm going to look specifically at a question at Leaving Cert on slope of a line. Before we do that, we'll have a look at the syllabus on slope. And this is what the Junior Cert syllabus says about the slope. Students learn about the properties of lines and line segments, including midpoint, slope, okay? Distance and so on. At higher level, the slightly darker print is the higher level. They have to know about parallel and perpendicular lines. And you have your learning outcomes, okay? Students should be able to. Now, explore the properties of points, lines and line segments. Up to this, at Leaving Cert and at Junior Cert, most of the questions on slope were a straightforward question, find the slope. Or it might be find the equation, and obviously you have to get the slope first. And that became a procedural question. There's a formula for finding the slope, y2 minus y1 over x2 minus x1. You've got your slope. Same with the equation of the line. And a lot of students did not understand what slope was about, what you meant by the slope of a line. So we're expected to teach them more than just the formula. So I want to emphasise the procedures are still there. They still need to be able to find the slope, find the equation, and so on. But they also need to understand what the slope is about. So explore the properties of points, lines, and line segments. And at Leaving Cert, the Leaving Cert syllabus looks like it's very bare on the slope, but the Leaving Cert syllabus is a continuation of the Junior Cert, so they're not restating the material that's on the Junior Cert for it. But at foundation level, you've got that little bit about parallel and perpendicular, and the Leaving Cert ordinary level, solve problems involving slopes of lines. So with all that in mind, let's have a look at a question. This question was given on this sample paper. And you're given some slopes here and you're given some lines here. So what do you reckon the question is? Match the lines to the slopes. Now that's in your booklet on page 10. And you can see to get the correct answer, students needed more than just being able to find the slope from 2 points. They had to understand the slope. All right? And work them out. Now, also the marking of this is a bit different to what it would traditionally, how it would have been traditionally marked. Any questions that come up with filling in things into tables, they usually did them on the table, correct or incorrect. Usually what we call hit and miss. So if there was 10 marks going for that, there was probably 2 ways it could be done. It could be 5 twos, you got it right, you got it wrong, whatever. Or else it might have been 10 for the whole lot and -3 for, if we're going on slips and blunders, -3 for every incorrect one, but you would get no lower than 3 marks. That's what's called the attempt mark. In this one, it wasn't just how many boxes you have correct, and this is going to make the marking of these papers, I suppose, a bit more difficult, but a bit more interesting. It also looked at the question overall. What I'm going to do now is show you a series of incorrect answers. I'm going to have the correct answer. I'm going to have the correct answer here, and I'm going to have the incorrect answer filled in the left hand, the one that's there now, and we're going to look at how it was marked. Before I do that, this is a piece from the actual trial report. It may be noted that the marking scheme for part A, which was this part, was not based on how many of the particular cells were filled correctly. It was instead based on the level of understanding that is evident when the answer as a whole is considered. This minimises the effect of guessing and concentrates on rewarding evidence of achievement of target skills. Now the target skill here is understanding slopes. Obviously somebody gets it all right, no problem, you assume that they understand it. Now here's the correct answer in the green box, but look at the incorrect answer on the left hand side. Can you see how many boxes or how many cells we have correct? Just one. But have a look at the incorrect ones. Can you see anything else correct in the rest of this answer here?
Yeah, no positive slope and negative slope.
Yeah. They've made a mistake between the magnitude of the slopes. So they do know that positive slopes, let's say, are that way, and the negative slopes are that way. So they have got more than one thing right. They have the one box right, but they have more than that. They know the difference between negative and positive slopes. So they got a partial credit for it rather than they got quite a few marks for it, rather than just saying just one right. Which if you think about it is very fair. Okay, but on the traditional way it was kind of hit and miss, and that was it. Okay, let's look at the next incorrect one. Anything right here? The same one again, the O, and but nothing else really, is there? They've mixed up the positive and the negative, so they just got marked for that one that was correct. Now this is the interesting one, and this one caused, well, I won't say about it for a moment. Sorry, that one. Any of them right there? K is right. How many marks do you think this got?
No.
Why would you say none?
Because they don't have any understanding of the slope.
Absolutely. Absolutely. So while students might benefit from this marking, where they've got something like the idea of the slope right, I suppose the negative or downside of it is, if this was in the old traditional way, they would have got the marks for this one correct. But that's not showing any understanding of slopes. Now, this is again another extract from the report. The question should not have posed any difficulty for a candidate with an understanding of the concept of slope. The level of performance may be taken to indicate that concentration has remained on practicing routine procedures rather than on the development of conceptual understanding. So we have to teach the understanding as well as the procedures. Interesting thing that came up between ordinary and higher level. They got pretty much the same question. But obviously they got different, same information, but they got different questions to be answered on it. And the wording was just ever so slightly. So in your booklets on page 11, you have this question. What you basically have here is that an economist wants to find out the length of time people spent in school and the amount of money they're earning. And we have the information here. And part of the scatter plot is drawn for the students. And then they have some specific questions on it. Okay? So let's have a look at the questions. You can see the higher level students got more questions and more difficult questions than the ordinary level students. So if we look at the questions with regard to the ordinary level students, okay, the last three rows of data have not been included on the scatter plot. Insert them now. So they had to put in the last three scatter plots here on the graph. Now the next question the students were asked, and I'm leaving this slide up so that we can look at the graph. What can you conclude from the scatter plot? Now we're trying to see if there's a relationship between the length of time a person stayed in school and the money they're earning. Okay, so here the answer we had here, the more you spend in school or the longer you spend in school, the more you learn. Okay, because there's a couple of exceptions, we need to temper our language just a little bit and say something like, the longer you spend in school, the more money you tend to earn, or the more money in general you learn. And this is where we have difficulties with students again. If they get lots of practice at this, they should be able to not to be too deterministic. Can't say emphatically, the longer you stay in school, the more money you earn, because there's a couple of people where that doesn't happen. That second part of the question, which was what can you conclude from the scatter plot, tested the candidate's capacity to interpret the information presented in order to draw a conclusion. Now, if you look at your page 12 of your booklet, part 3 of the ordinary level question and part 8 of the higher level question are very similar. Okay, the student collected the data using telephone survey. Numbers were randomly chosen from the Dublin area telephone directory. The calls were made in the evening between 7 and 9. There was no answer. If the person who answered did not agree to participate, then another number was chosen at random. And the ordinary level students were asked to give one possible problem that might make the results of the investigation unreliable, whereas the higher level students were given the exact same question, but they were asked for 3 possible answers. And you see what the trial report said on that. It is worth noting that this part did not require connections to be made between the mathematics and the context. This may indicate that candidates are relatively comfortable describing and understanding real-world issues and concepts, but not as yet able to meaningfully relate these to the mathematics they're engaged in. In other words, they answered this part of the question quite well, but they weren't able to interpret the original information in a mathematical way. So it was just a snapshot in time of where students were, and there were the students in the project schools. They had done a year of project maths. They had done 5th year. They were into the autumn of 6th year. And this was a snapshot in time. But it was reading this has been a great benefit to teachers, because it told them what gaps that needed to be filled in and how to get students to answer the questions. What kind of answers would you suggest students might come up with for that part of the question? What's wrong with the way this data has been collected? Only the Dublin area, right? Not necessarily representative of the country. Okay, yeah. Anything else?
Between 7 and 9.
7 and 9.
A lot of people.
Yeah.
Work late or
Exactly.
work shift work.
Yeah. So you've got two. So like students will have learned in doing their statistics all about sampling. It's part of the syllabus, and Strand 1 now is all about sampling and how to avoid bias in the sampling. So they obviously, from the way they answered this question, that had been covered very well. Okay, so there's just our 3 questions put in. The higher level students then were asked to put in the line of best fit. And the line of best fit is by eye. So we got this line of best fit. That was done with the Geogebra, but as long as there's quite a degree of tolerance given for the line of best fit. They're not expected, even though some of the calculators will give them. When you put in the points to get your correlation coefficient, with some of the calculators it's very quick. It's only another few buttons and you've got the slope of the line. And they're not expected. It actually clearly states in the syllabus, by eye. A line of best fit by eye. When they have that line of best fit by eye, that was part 4. If you look at your booklets again, add the line of best fit. Use the line of best fit to estimate the annual income of somebody who has spent 14 years in education. So we're now reading from this. So you've got your 14 years up to here and across here. So you're looking at something over 40,000. By taking suitable readings from your diagram or otherwise, calculate the slope of the line of best fit. Now the otherwise will be your calculator, which will do it for you. But what students needed to do here was probably most of them would do it, would be the first way, to take suitable readings. So you might take, I'd always look for points where it's actually crossing some grids. So I might take that point there, 1235, and something else. Well, we've just had the 14 here. Why not take that one? Okay. Be careful about here because it is not on it hasn't come back to, if your scatter plot has come back to 0 on the x-axis and 0, you can get the y-intercept, but you can't in that one. So here are students at higher level actually being asked to use y2 minus y1 over x2 minus x1. So the procedures are still there. And then they're asked to actually calculate the slope of the line of best fit. And then they had to explain or interpret the slope in this context. So they had to interpret the slope as well. So you get an idea from these couple of questions, the difference in the style of questions from the very procedural questions that we originally had on our Leaving Cert. And just one from foundation level, not to leave, we've had ordinary, we've had higher. Foundation level. Sean's French teacher gives tests that are marked out of 10. Sean got the following results. So the first question that we was asked, what was the normal question you'd be asked with something like this? Find the average or find the mean. Okay, find Sean's mean mark for the 5 tests was the actual question that was asked. Anya got the following results in the same 5 tests. She was not in for the 4th test. You could be asked for her mean of the 4th test. The actual question that's asked, is Anya better or worse than Sean? And give a reason for your answer. So it's not just enough to say, yes, she's better or no, Sean was better. So let's have a look. She's never done any worse than him. Yeah. She's done the same or better. And actually a student wrote that down. So that's one way of doing it, comparing like with like. So first exam she did better, second exam she got the same, third exam she got better, and the one that she missed we don't know about. But just looking at the ones that were done, it's the best way of comparing them, because that one that she didn't do, we don't know whether, like if it was, what kind of a test it was he got 10, which there might be some aspect of the French. Maybe she skipped it that day because she didn't know what was on. Anyway, look, let's have a look. We finish up by looking at a few of the comments. Full credits were awarded to the following answers. So the dark print are the answers that the students wrote, and the light print are the comments from the trial report. So yes, now the yeses was written down, and that was interpreted as meaning yes, that Anya was better. Anya always got the same or higher than Sean, apart from when she wasn't in. Okay, so that's kind of, you're checking like with like. Remember, these are foundation level students. So out of 50, she got 27. Out of 50, he got 35. But Anya wasn't in when he got 10. So that's this is the comment on it from the people writing the report. The candidate has given an insightful analysis of the available data to support the conclusion. It recognised that Sean scored better overall, but points out that closer examination reveals that Anya matched or outperformed him on all common tests. Don't know, here's one now, and this person got full marks. Don't know. But why? Because she missed one of the tests, so the results would be unfair. And this person, now it's probably because it was foundation level that this person got full credit for this. The candidate is displaying at least as much insight into appropriate use of data as someone who compared the means and ignored the issue of absences. So it's an interesting way of looking at questions and an interesting read. I can tell you that report is an interesting read. Okay. So, to finish off this slides, I'm going to just show you the few websites then. Leaving Cert, this is the changes that are there, maybe not as pertinent to you, but to give you some idea. The Leaving Certs are sitting, from the national rollout, are sitting their first exam in June. Okay, at higher level, paper 2 is the only thing that's going to be changed. Paper 1 remains the same. Paper 2, at higher level, everything has changed. Now there are 300 marks for each paper, and section A is concepts and skills. That's more of the routine material. And section B, context and applications, problem solving. And in higher level, that covers just the 2 strands, 1 and 2, statistics and probability, and the whole geometry section. geometry, trigonometry, coordinate geometry. In ordinary level students at the moment, their question 1 is area and volume, and that is not changing. So there is one 50-mark question on area and volume from the old syllabus. It's in section C. There's your 50 marks. So that 50 marks is out of the pot that's left for the other 2 strands. So the other 250 marks are divided evenly between section A, the same as the higher level one, concepts and skills, but this time there's only 125 marks going, and context and applications. And at foundation level, there are two area and volume questions here, the 100 marks, and then the other 200 marks are divided evenly between the concepts and skills and the context and applications. Now the department, and on the State Exams Commission website, there are sample papers that the department issued there before Christmas. And it shows these are the exact way the papers have been divided up this way. Okay. Another thing too is that they're going to answer the papers on the actual exam paper. Now the booklets that you would all have done, all the little book, the sort of foolscaps or the A4 pages, they're gone for the Project Maths papers. They're still using them for paper 1 because paper 1 hasn't changed. And the space they're given for the answer to the exam papers has, in most places, has little grids on it. So they're writing on the squared paper, except when they have constructions to do. They give them a blank piece like this when they have constructions, because obviously the squared paper is very distracting for constructions. So there's the State Exams Commission website, and that's the web address. But see down here, Project Maths. If you go down to there and scroll down that, you get all the sample papers that were issued to the project schools as well, the exams, and that's where this report is. So that's on examinations.ie, this report. There's all these different bodies. I don't know if you're aware of it. There's many different bodies that are involved with Project Maths. But we have, obviously, the State Exams Commission examining. We also have, Project Maths. Project Maths ourselves, one of my colleagues, in fact, took out all these papers that are out there already, the sample papers that were used in the project schools and the actual exams used in the project schools. And we've put them into 3 separate booklets. And we have clearly marked on them where things have changed since. Remember, the nature of a project is that the project schools did some things and they were then changed. For example, the very first year the project schools did the exam, vectors was on it. They're gone off it now. So if you look at the 2010 sample paper and the 2010 real paper, you'll see vectors on it. But on our booklets, it's clearly written across it that this is no longer on the syllabus. Some of the statistics were changed after the first year as well, and off the top of my head I can just think cumulative frequency curves are no longer on it. So there's a question on that. It clearly states on it, this is no longer on the syllabus. That's the NCCA website. Now the NCCA, National Council for Curriculum and Assessment, they're the body that devised or came up with the new syllabus. And I'm not too sure if you're aware of the composition of the syllabus committees, but you have members, you have second level teachers and you have people from third level as well. So you have people like the ASTI has 2 representatives, the TUI has 2 representatives, the Irish Maths Teachers Association has 1 representative. The various management bodies in second level have, there's 3 management bodies, the voluntary secondary schools, the community and comprehensive schools and the VECs. They have a representative each. And then at third level, you have people from universities and you have people from other third level, the ITs, other third level. Who else? Oh, yeah, of course, you have somebody from State Exams Commission and you have somebody from the inspectorate. At this stage, we have 4 different syllabus out. That's the one, the Leaving Cert one, which our present 6th years are using. Right? That's the Leaving Cert 1, the present 5th years are using. Because this contains just strands 1 and 2 and the old material from the other course. This contains strands 1, 2, 3 and 4 and just the residue of what's left over from the old course. And the same thing then with that's our second years. So that's only strands 1 and 2 and that's going to be examined in 2013 and that's our first years. And we're going to have another lot with all 5 strands coming out in September. So a lot of the material is found down these tabs on the left-hand side here. I suppose today's workshop is workshop 3. So all the material that I have been using today is up here online. If you're interested in what's happened in the other workshops, you can see they're all there. We've emphasised the necessity to find out what the students' prior knowledge. So we had our diagnostic test, for example, in the fractions. Also, when you're given problem-solving questions, that you're not pitching them too high, that you're aware of the students' prior knowledge. In a problem-solving question, effective questioning is very important, that you don't tell the students how to do it, but by asking them questions, you elicit the answer from them. And that's all to do with students exploring the question, discussing the question, and explaining their answers. We looked at group work, and again, I mentioned differentiation of the questions between you, and then to monitor progress, because remember, the whole thing is assessment for learning, as well as assessment. I probably emphasised today with looking at the terminal exam, the assessment of what was going on. But with assessment for learning, the whiteboards are very good for that. We had self-assessment to some extent in the teaching and learning plan on complex numbers. And it's okay. It's okay. Give your students permission to get the wrong answer. Don't put the big emphasis on the answer. It's on the process. I remember we started out with the saying it was that we're on a journey, and it was better to travel well really than to arrive. So we want to see the process. So thank you all very much for your participation in today's workshop. It was lovely to work with you, and I hope you got something out of it.